Section 4.4, the fundamental theorem of calculus. In calculus, we learned that the definite integral is the net area between a function and the x-axis. We use a simple idea to find area. Area of a rectangle is base times height to approximate area for a given curve. So again, we subdivide the interval into n subinterval. Each one have length delta of xi, and the height is f of ci for some point on the interval. And we add up all these n subinterval and then take the limit as n goes to infinity to get the definite integral from a to b f of x with respect to x. In practice, it's impossible to take the limit every single time. So we introduce a fundamental theorem of calculus. Let f be a continuous function on the interval ab. Then the definite integral from a to b f of x with respect to x equals capital F of b minus capital F of a, where f is an antiderivative of little f. That means capital F prime of x equals f of x. Let's take a look at an example of how to apply the fundamental theorem of the calculus. If we need to find an area under the curve for f of x equals x between 0 and 3, well, geometrically it's a triangle. So the area is just 1/2 times the base 3 times the height 3 equals 9/2. However, we have learned how to use the integral representation of the area. So this area is just integral from 0 to 3 absolute value of x dx. Again, whenever we're looking for the area, we must take the absolute value for the function because area is always positive. But in this case, f of x is positive in the interval 0 to 3. So we can simply write down as x dx. Now, according to the fundamental theorem of calculus, we first find the antiderivative of x, which is x squared divided by 2, and that is application of the power rule. We evaluate at 0 and 3. So when x equals 3, we get 9/2, and then we need to subtract when x equals 0. So 0/2. The final answer is 9/2. Which is exactly the area when we calculate geometrically. In the second example, we also need to find the area of the curve, but in this case, the curve is not a simple geometric figure. Let's take a look at the graph. If we just take the regular definite integral from 0 to 3, x squared minus 3x plus 2, we're only going to get the net area. That means it will add the area from 0 to 1 and subtract the area from 1 to 2 and then add the area again from 2 to 3. But in our case, we want the geometric area instead of the net area. So again, we need to take the absolute value of this function dx. Now in this case, the function is not always positive in the entire interval. So we will need to break this integral into 3 parts. The first part is from 0 to 1, where the function is positive. So we simply just rewrite the function. For the second part, from the interval 1 to 2, the function is negative. So if we just simply calculate the integral from 0 to 2, we will get a negative number. But because area must be positive, we need to subtract the negative area. And finally, we will add the positive area from 2 to 3, x squared minus 3x plus 2 dx. According to the fundamental theorem of calculus, we will need to find the antiderivative first. So we have x cubed over 3 minus 3x squared over 2 plus 2x, and do not forget this x. So evaluate from 0 to 1. We need to subtract the same thing, x cubed over 3 minus 3x squared divided by 2 plus 2x, and in this case we evaluate from 1 to 2, and plus antiderivative x cubed divided by 3, subtract 3x squared divided by 2 plus 2x from 2 to 3. So we plug in x equals 1. When x equals 1, we get 1/3 minus 3 over 2 plus 2. So the value for this function is 5 over 6. And we subtract when x equals 0, the function is just 0. Then we need to subtract the second evaluation. So plug in x equals 2, we get 8 over 3 minus 6 plus 4, which is 2 over 3. We need to subtract capital F of 1, we just find it is 5 over 6. Then we need to add, evaluate, when x equals 3, we get 3 over 2, and we need to subtract when x equals 2, we just got it is 2 over 3. Now use a calculator to evaluate this expression. The final answer will be 11 over 6. And we can also verify this calculation by using computational software like Wolfram Alpha. Next, we're going to take a look at more examples of how to evaluate integral, just a simple integral, by using the fundamental theorem of calculus. So this integral from 1 to 2, 3x squared minus 2 plus 3 over x squared dx. Now in order to evaluate or find the antiderivative, we need to change everything to the power form. So we get 3x squared minus 2 plus 3 times x to the negative 2 power dx. And we will have to, now when it's in the power form, it's very easy to calculate the antiderivative. And the antiderivative is power increased by 1 divided by the power minus 2x plus 3 times, again, power increased by 1, negative 1, divided by the power. And we evaluate from 1 to 2. Now we write this in a simplified form. 3 times negative 1 is negative 3. X to the negative 1 power is 3 over x. Evaluate it from 1 to 2. When x equals 2, we get 8 minus 4 minus 3 over 2. When x equals 1, we get 1 minus 2 minus 3. So we get 4 subtract 1/2 is 2.5 minus 1 subtract 2 subtract 3, we get negative 4, so it's plus 4. So the final answer is 6.5 or 13 over 2.